Okay, today what we're going to do is we're going to put everything together we've learned in the previous three videos, and we're going to be able to go back and forth between moles and grams, and also moles and particles, but we can also make the jump from grams all the way through to particles. Now, how can we do that? Well, it's important to remember that as long as we have conversion factors, I didn't leave enough room there, we can move between as many units as we'd like. So, for example, if I ask you how many inches there are in miles, there's very few of us that know the conversion directly between inches and miles. However, we do know how many inches there are in a foot, and hopefully, at least we might be able to look this up, we know how many feet there are in a mile. So if we start off with a normal problem, this is going way back to when we did regular conversion problems. If we start off in a table and we went, oh yeah, we have 3.00 miles, couldn't we put that in the upper left-hand corner, and then couldn't we use either of these two conversions? Now, the conversion we use depends on where we want to go. Now, we have miles here. Using the conversion of foot to inches does not help us cancel out miles, but this one, miles and feet, does. So couldn't we go 1 mile on the bottom, and then 5,280 feet on the top? And when we do that, that allows us to cancel out our miles, and now we're at feet. But if we want to go one more step, couldn't we go, oh yeah, for every 1 foot, there are 12 inches. And we could cancel, well, that's supposed to be an N. And we could cancel out our feet here, and the unit that would be left over would be inches. And then it'd just be a matter of doing some mathematics, because wouldn't we multiply 3 by 5,280 and divide it and multiply it by 12 to get our over number of inches? And the sounds you're going to hear in the background are my calculator frantically working. And the answer there would be 190,080. We don't like the significant figures in that because aren't we only allowed to have 3 significant figures? So we'd have to actually draw our line of death here, which means probably we get to make our exponents. Remember to do this, 1, 2, 3, 4, lefty, largey. Wouldn't that be 1.9? And wouldn't this 8 make this 0 into a 1 times 10 to the 4th inches? Now, we're not going to be working with feet and inches and whatnot, but I want to go back to the stuff that we've been working with up to this point. And we've been dealing with particles over here. That's particles. Moles in the middle. And over here we've been dealing with mass, but I'm going to call mass grams today just to make it a little bit simpler. Again, this is particles, although I think I'm making more of a mess by doing that. Now, we were able to go back and forth between moles and particles because we know that 1 mole of anything is equal to 6.022 times 10 to the 23rd particles. So as long as we have that conversion right here between these two, we can go back and forth between these two things. When we want to go between moles and grams, remember in the last video, we used molar mass. So we're going to do that again today, and we're going to go, not only are we going to go from moles to grams or from moles to particles, but we're going to do a 3-step. Now, the thing you have to be aware of is this. Depends on where we start. If they start us off on a problem over here on grams, we can't jump from grams all the way over here to particles. We first have to go from grams to moles, and then moles to particles. Similarly, if we start over here at particles, we can't jump directly over here to grams. That wouldn't work. And by the way, when we say particles, that's anything. That could be like molecules, or that could be atoms, or that could be formula units, or whatnot. So the best way to work on this is to practice, and we need a periodic table to do any of these problems. So I'm going to remind you that the numbers underneath each of these elements here, those are the molar masses that we may need whenever we're going between grams and moles of something. So let's take a look at a particular problem, because the only way to do this best is to do it this way. So let's say I started you off and I gave you 4.22 grams of aluminum, and I wanted you to go to atoms of aluminum. Now, if we take a look back at our table up here, that would be starting over here at grams, right? And we need to get over here to atoms, since atoms are a particle. But there's no way to do that directly. So first we have to go from grams to moles, and then we have to go from moles to particles. Now, the only way to go between grams and moles is by using the molar mass that we find on the periodic table. And since we're dealing with aluminum, we're going to look up aluminum on the periodic table, and aluminum happens to be right here. And if we look up its molar mass, it's 26.98. And what that number is that's 26.98 grams per mole. So I'm going to write this over here, 26.98 grams per mole. That's one of the conversions we're going to use. But we don't want to go from grams just to moles, which is what this would allow us to do. We want to go from moles to atoms. And we know this other conversion. We know that 1 mole is equal to 6.022 times 10 to the 23rd of any particle. In this case, the particle is an atom. So let's set the problem up like we normally would. We're going to start off in our little table, and we're going to go, all right, 4.22 grams of aluminum. Set up our table, and the first thing we're going to have to do is we're going to have to use this conversion factor to get from grams to moles. So again, our goal is to go from grams over here, first to moles, and then again to particles. And the particle happens to be an atom. So when we come back over here, we need to use the molar mass, and the way we set that up is by putting the 26.98 down below. And that is grams, because the grams here need to cancel. And up above, we're going to put 1 mole of aluminum. I failed to put the aluminum down below here as well. The other thing I want to point out here is this. I reminded you in the previous video, if you ever using conversion with moles, both with moles to grams, or like in this case right here, or between moles and particles, it's always 1 mole. So if you put 26.98 moles, you've done something wrong. The nice thing about this right now is that we can cancel out this unit right here. Grams cancels out. Now we're at moles, and if we stop right here and we did the math, we would now have a math problem. We have the answer to how many moles there are in that number of grams. But we don't want to stop right there. We want to keep on going. So we're going to keep on moving here, and the conversion we have to use now is the conversion between moles and atoms. I'm going to go 1 mole of Al for every 6.02 times 10 to the 23rd atoms of Al. I'll make this go a little bit longer. Now, then all we have to do is we have to remember, anytime you have a line, that means multiply. So we have to multiply and multiply, and then we're going to have to divide everything on the bottom. So there's only 2 numbers we have on the top here, 4.22 and 6.02 times 10 to the 23rd. So we're going to multiply those 2 numbers together, and we're going to divide it by 26.98. Well, off screen, math happened, and I did this, and I ended up with this, 9.42 times 10 to the 22nd atoms of aluminum. And it kind of makes sense, because if you think about it, if 1 mole is 26.98 grams, if we have only 4.22 grams, would you agree that that's less than 1 mole? Which would mean that our number here should be less than 6.02 times 10 to the 23rd. Hopefully that makes sense. Now, what if we went the opposite way? What if we started off with molecules? Now again, you may look at molecules and go, what the heck, I don't understand. Listen, a molecule or anything, an elephant, a T-Rex, an atom, a formula unit, those are all just particles. And if we start off with a particle, the only place we can go ever is to a mole. If they ask us to go all the way to grams, that means we're going to have to do 2 steps. First go to moles, and then go to grams, and that's what we're going to do. The other thing you might be concerned with is you might go, well, wait a second. Here they're giving us CO2. So if I start off with my problem, I'm going to go, all right, we have 4.550 times 10 to the 31st molecules. I'm going to abbreviate that molecule of CO2. Now, I'm going to put that in the upper corner of my table. The only place I can go from molecules, which is a particle, is I can go to moles. And so in order to do that, I'm going to use the conversion factor, 6.022 times 10 to the 23rd particles per mole. Well, what's the particle in this case? Well, it's a molecule. So I'm going to go 6.022 0.022 times 10 to the 23rd molecules of CO2. My computer, while I'm doing this, is lagging really hard. That's why I'm having this issue. Sorry about that. It's been pretty busy. It's been on pretty much the last 48 hours straight. That's per 1 mole of CO2. So we've set this up in such a way that we can cancel out the molecules of CO2, cancel each other out. And we're left with moles. And again, if we were to stop right here, we'd actually know how many moles there were in that number of molecules. But the problem doesn't ask us to go to molecule, it asks us to go to grams. And here's what we're missing. We need to figure out what the molar mass is, because in order to go from moles to grams, always, the only way we can go between moles and grams is by using the molar mass. And what we're doing in this case is we're using CO2. So if I'm doing CO2 here, I have to get the molar mass of carbon and 2 oxygens together and add them up. So this is kind of like in the instructions I said we're doing 2-step problems, but really they're 3-step problems. Whenever you have to figure out the molar mass of something, that's the 3rd step. So if I have 1 carbon, that carbon's molar mass is 12.01 grams per mole. I have 2 oxygens, so I'm going to have 2 molar masses of 16.00 grams per mole. And if I add them together, again, my computer's having some issues, it's going to be 44.01 grams per mole. That is the molar mass of CO2. And since I have that now for CO2, I can go back up to my original problem and I can plug that into my problem. So I can go over here and go, all right, how do I put this mole in the grams? Well, I have to put the mole in such a place as to cancel out moles. So I'm going to put 1 mole on the bottom of CO2, and on the top, I'm going to put 44.01 grams of CO2. Now, again, what cancels for us? Well, don't we have on the top moles of CO2 and the bottom moles of CO2? And if I hadn't been having, again, this lag, you see I have grams of CO2 on the top, which is what we're trying to solve for, which is good news for us. Again, off-screen math happened, and when I did the math on this, I ended up with 3.325 times 10 to the 9th grams of CO2, which is a lot of CO2. Now, this can be, you can go back and look at this a number of times just to try and see the steps, but we're going to be practicing this because the best way to do this is to practice. I'll be giving you some worksheets and you'll have the answer keys to work on it, and of course I'll be available in class. So if you look at this video for the first time, you're like, man, I don't understand this, that's okay. We're going to work on this together. So have a great night, and I will see you in the next video. Take care. Bye.